Hi there, good evening. Today I'm playing with gold. Yes, that's part of my collection, what I collected over the last 2 years about. So that's all kind of gold contacts or gold fingers as they are called. For example, that was from a server power supply. That was probably from a RAM module. That was from a power supply too. And that was probably from a PCI card or something like that. So I collected all these gold fingers over the years, and now it's time to release the gold from the PCB with iron trichloride, 40% solution. Iron chloride is a chemical that was widely used by electronics hobbyists for making their own PCBs because it's an excellent etching agent for copper. It is also used by artists who make copper relief stuff like that, or also for brass does also work. Or if you want to etch some brass parts with numbers or dials or stuff, that's what you need. The problem is, since PCBs are now cheaper to let them make in China, you know, the obvious PCB makers, a PCB costs you a couple of dollars. You send them the design files and they send you the properly made PCB back. So I found a company that is still selling this because iron chloride is used, for example, for water treatment, but of course only in large quantities, so it's always difficult to get a medium quantity. So that was the minimum I could get. It's 40 kilos. That's about 30 liters. And because that's quite a little bit heavy to carry in one hand, so I had to distribute them in 3 containers. Each one is half full, so 30 liters, 10 liters each, that's it. And here we have the gold, well, how could I call that? Well, the gold maker, let's call it the gold maker. So what is it? It's a heated kettle where you can put some water inside, and I have some nice glass jars here. They are from IKEA. And here is a grid, and you fill it up until all the glasses stand in the water, about half in the water, and then I heat it up to 50 degrees centigrade. Here is the dial. You can set all temperatures up to cooking temperatures, but that's a little bit too much. I don't want to cook because, well, I fear there are some fumes escaping that are not very healthy. Well, speaking about fumes, I have this cover here, and it has a little fan on the top, and underneath there is a hole. The idea is to collect all the fumes and vapors. At 50 degrees Celsius there shouldn't be too much. And then we vent that out by this hose that gets connected somehow to the fan, and then I will hang that out of the window. Yeah, that's the plan. Let's see if it works. Maybe some theory about that. So we have, for example, that one. There is gold plating on a copper PCB. So if we remove the copper, the gold simply falls off. So that's the plan. Okay. That's my homemade distributor valve here with 1, 2, 3, 4 screws that regulates the amount of air that goes through these hoses. The pump is from, I don't know, some medical device. I found it in the scrap. That's from the scrap. Hoses are from the scrap. The only thing I bought was this kettle here and the glasses inside. Okay, that's about 5 liters of water and it seems that's just right. Yeah, you may have noticed that I spilled some water into the glass, so that's not a problem because the iron chloride is already a water solution, so a little bit of more water, some drops, doesn't count. Okay, let's add the chemical. Oops, was already open. I fill it up until everything is submerged. Okay, so I need some kitchen paper because I don't want this stuff to drop on my floor. As I said, it's not very dangerous, but it makes pretty nasty stains. So it's time to connect the pump and see how well that works. Seems that works pretty well. I may have to adjust it a little bit. So that's number 1, that needs a little bit more. Oops, not that much more, that much more. And then I have number 3. That could also bubble a little bit stronger. So that is extreme bubble. I just wanted to agitate a little bit. Okay, and you may probably ask, what does this all cost? Must be expensive. No. Well, I calculated how much material I have. It's total of 6.4 kilograms. From my experience, I can say it's about 100 gram makes 1 gram of gold. So I expect about 64 grams of gold from all that and the stuff that is already in the kettle. At the moment we are about 52 Swiss francs per gram. Well, I think it's even 54, but let's stay on 52. In US dollars is about the same number at the moment. So I expect that this will be 3,300 Swiss francs worth of gold. Now, the chemicals are relatively cheap. So this 40 kilo canister cost me about 50 bucks. The only problem was the transport. They brought it with their own truck, so you can't ship that with post or with DHL. Well, maybe they do that, but it's dangerous goods, and that costed alone 120 bucks. So let's say, including all taxes and stuff, that's 200 bucks for the chemicals. Then we have the electric heated kettle, and that one was surprisingly cheap. So the whole kettle with everything, with cover and the grid inside, not the glasses, is about 100 bucks. And the 4 glasses in IKEA was about, I don't know, maybe 60 bucks complete. So we have 200, 300, 360, well, maybe 400 bucks investment and 3,300 that come back from the gold. And of course I can use that kettle here many times. I hope, well, if it survives. I can also use the pump many times. The only thing I have to replace is the chemicals. And I heard it's already heated up to 50, so I placed it on 40 because it overshoots a little bit. If I put it higher, the light goes on. If I put it lower, yes, I think, yeah, that's certainly hot enough. Let's place it to 40, and in reality it's 50. Okay, fan is spinning, hose is attached, goes outside the window. Let's see what happens tomorrow. Okay, this soup has now cooked for 20 hours and, well, let's see what's happening. There's a lot of condensation here on the cover. It seems that my fume exhaust system is not very effective. Well, it turned pretty black, but there's many of the gold contacts have already dissolved, or the copper has dissolved and the gold has gone. And this is my filter with an attached cover for this canister here. This canister is now empty, and the filter itself is some curtain from IKEA. And the only thing I had to look is that it's not made of nylon or polyamide, because nylon is the only plastic material that is dissolved by the iron chloride. All the other plastics, PVC, polyethylene, etc., no problem, but not nylon. I realized that when I built my first gold washing machine with a motor, with a drum that rotates, with nylon gears. And after a while, the gears lost all their teeth. So I thought, maybe a mechanical failure, but I found out it's the iron chloride that dissolves the nylon. So whatever you take something else.